Today we're going to talk about loading simulation. The current standard approach to calculating pass-match ratio is to take the volume, the published volume of a dump body and the published volume of the loading tool and divide them. With loading simulation, we actually take into account many more details. We actually simulate the underlying geometry. We have the inherent properties of the material included, things like angle of repose, and the kinematics of the motion of the loading tool, as well as the relative motion between the loading tool and the dump body itself. So now we're able to actually calculate a more realistic volume or capacity, which leads us to a more accurate pass-match ratio. Using standard pass-match, some mining companies have found after the equipment selection process is complete that they're not meeting their expected payload capacities. We can use loading simulation to close this gap now, since we're able to include the mine's specific application details. And we're also able to use loading simulation to design application-specific equipment like dump bodies, for example. We start by creating two piles. One is a heaped pile with a 2-to-1 ratio on the top. The other is a scooped pile. Both of these piles will be shaped by the underlying geometry of the bucket as well as the properties of the material itself. To create a more realistic pile, we actually scoop the material up in the bucket using the kinematics of the bucket and machine. And we can see in comparison here that the orange bucket has more material than the heaped bucket, and this is due to the fact that there's teeth on the bucket, the size of the material that's retained in the bucket, as well as the kinematics of the digging motion. Now we take the heaped and scooped piles and use them to simulate 6 different configurations to see how many passes are needed to load the truck. We have 4 heaped pile simulations and 2 scooped pile simulations that you see in the orange buckets on the right. As the loaders begin to move the material in the simulation, you'll see colors changing, which represents the speed of the particles. And as each consecutive bucket comes in and dumps its load into the dump body, the material begins to settle into the pile. And as the dump body begins to fill up, you'll see material flowing over the side walls and off of the tail of the dump body until the final load is settled. And we use this final load that's settled in the dump body to calculate the pass-match ratio. Here we have the pass-match ratio results for the 6 configurations that were simulated. It ranges from 6 to 8.76 for the heap pile and 4.9 to 5.62 for the scooped pile. And here we have the 2 pass-match ratio results for each dump body that did not underfill the dump body. For the fully loaded dump bodies, we have a pass-match ratio of 8.76 from the heaped pile and 5.62 from the scooped pile. Let's compare these numbers with the standard calculation that uses published dump body capacity divided by a published bucket load capacity. Calculating those results gives us a pass-match ratio of 6.94, which is higher than the scooped pass-match ratio you see here of 5.62. For reference, we are showing here a comparison between the settled dump body piles and the SAE 2-to-1 standard volume for this particular dump body design. Loading simulation is applicable to mining companies that are considering purchasing equipment or replacement truck bodies. Loading simulation is used to avoid losses from mismatched equipment and to maximize productivity. OEM and aftermarket companies can leverage loading simulation to develop application-specific design configurations. This can be used to maximize value of their products and to increase productivity for their mining customers. The VPDS team has many years of experience in developing mining equipment products. VPDS loading simulation expertise can be leveraged to provide customers with purchasing confidence in their equipment selection process or efficient product development services. More information is available at the following address, as well as a white paper that includes more technical details of the simulations shown in this video.